Oh, there we go. Okay, thank you. All right. So our next speaker is Seth Goodman. He is a research scientist at AidData. His background is computational geography and engineering, and he's going to be going over the GeoQuery platform, which is coming out of AidData. So, Seth?
Thanks, Carly. Let me just get my screen shared. All right, thanks for joining us today for this training session on AidData's GeoQuery tool. Just a reminder that all of these sessions will be recorded. So I've been with AidData for a bit over 9 years now. I've spent a lot of that time exploring ways to effectively leverage geospatial data from a number of different angles. That's included building spatial data pipelines, creating infrastructure to manage spatial data, using machine learning to extract information from satellite imagery, and operationalizing new research methods using that data.
Hey Seth, if you have a microphone, will you get a little closer to it?
Sure.
Let's try that. Thank you.
Is that any better?
It's a little better. Let's try with that for a little while. Thank you.
Okay. So one of the major connective themes across my work has been making geospatial data and methods more accessible for researchers, policymakers, and really anyone else who can benefit from it. Recognizing the value of geospatial data and Earth observation data in the development space, combined with AidData's own need for geospatial data, was really what drove the creation of this GeoQuery tool that has improved our own workflows over the years and has ended up helping many others incorporate geospatial data into their own work. So today, what I'm going to start off with is a bit of a high-level introduction to working with and managing the integration of geospatial data and how we approach some of the challenges associated with that when we were developing GeoQuery in order to make it as easy as possible for ourselves and other users. I'll then do a demo as we go through an example of GeoQuery to access a variety of data and show you can use that data with everything from basic spreadsheet tools like Excel to desktop GIS software like QGIS, or even with code, Python, R, State. I think we'll have plenty of time afterwards for questions, exploring GeoQuery, and even discussing potential applications if you have any in mind off the top of your head. So let's take a quick moment to emphasize why quality disaggregated geospatial data can be critical in development applications. Historically, and even to some extent today, a lot of the data related to development metrics such as poverty, child mortality, only been available at the national, regional, aggregate levels. And the problem, as you can see in this sort of simple visualization in the slide, is that national or other highly aggregated trends can easily mask these critical local issues. A net decrease in child mortality across the country could be obscuring specific areas where it's actually worsening. So using Earth observation and other geospatial data disaggregated at those fine subnational levels can be a powerful tool in itself, whether you're just tracking progress or of a specific metric or targeting future interventions. But we can go a step further and trying to understand when organizations intervene to improve conditions, how effective are those interventions and what geospatial conditions or features are actually driving outcomes. To do this, we use a suite of approaches collectively referred to as geospatial impact evaluations. That's obviously going to be discussed plenty over the rest of this convening, but a basic example of a geospatial impact evaluation is using spatial data to effectively mimic a randomized control trial where treated units are precise geocoded locations of some intervention, such as a new irrigation system, and control units are places without intervention but have very similar characteristics based on geospatial data such as temperature, rainfall, population. And then we use additional geospatial data on outcome metrics such as NDVI, vegetation indices from satellite imagery, to test if treated areas saw greater improvements than control areas. So GIUs are a great tool for evaluating projects, but they require good geospatial data. And fortunately, over the past decade, geospatial data has exploded in terms of quantity, quality, variety. And remote sensing satellite data make up a good chunk of that, but there's also lots of other important types of geospatial data that you can incorporate, like boundaries for administrative zones, household surveys on living conditions, road networks and other navigational data, geotag data from phones and other devices. And for all that variety of the sources of data, the fields and topics to which they can be used are really just as broad and extensive. So we all came to this convening to talk about agriculture, but even agriculture is inherently connected to many other fields. So environmental data on land cover and climate can reveal how agricultural choices are impacting the land around fields. the ability of crops to sustain population, provide nutritious food options can be critical to human welfare, which can be reflected in population trends, conflict reports, and household surveys. Agriculture also provides income and drives economic activity, which you can measure with nighttime lights as a proxy. And then agricultural practices can often be dependent on infrastructure that there may be geospatial data on, such as irrigation systems, canals, and other networks. So the reason why we can use all this diverse data for our work in these geospatial impact evaluations, and really just at its core, what makes geospatial data so valuable is that just by assigning a location to any kind of data you have that you can record about our world, wherever it's from, you establish this shared frame of reference. All spatial data is just information tied to a longitude and latitude on Earth in different ways. So you can merge together all this data on state boundaries with road networks and land cover and elevation, household surveys, posts from social media, to explore this unlimited kind of different spatial relationships that may impact the work you're interested in. Now, as great as geospatial data is and all for the potential it has, working with geospatial data in its raw form can be difficult. It requires finding and navigating many different sources of data that can be siloed across the internet in different organizations. You have to understand different geospatial data formats, have the computational tools, technical skills, resources to process that geospatial data. And often that can be substantial. You might need a high performance computing cluster to work with large data sets. And some of these limitations just end up producing gaps between what is actually available and practically accessible for many researchers and decision makers who want to leverage that data. So to overcome these gaps, we aim to leverage the fact that all that geospatial data has the common frame of reference to merge together all kinds of data for different geospatial sources in a way that anyone could access it and understand it without all these computational resources and technical skills or background in GIS. So by defining a relevant unit of analysis like administrative boundaries, we can join and aggregate any other kind of geospatial that overlaps with those boundaries using a relatively straightforward spatial operation that is known as zonal statistics. The example here in this slide illustrates taking NDVI values from satellite imagery at two different points in time as a proxy for crop growth and aggregating that to field boundaries that overlap with the pixels from the satellite imagery. And once you aggregate that spatial data to these common units, now you can easily view it in a tabular rather than spatial format. Each row simply represents one unit, and the columns are the summary values for the data that are in that unit. So for here, a researcher without knowledge of geospatial data, without GIS experience, could just take this output table and analyze or visualize the data in a way that's familiar to them. Now, while the zonal statistics process is fairly trivial to run for one small data set, it can be quickly computationally expensive and difficult to manage once you start getting to hundreds or thousands of these very large data sets, potentially covering the entire world rather than just maybe one small set of fields. So our solution to address these challenges and facilitate this use of geospatial data more broadly was to provide a simple and easy web-based tool that would allow anyone to quickly access geospatial data for anywhere in the world. So we want users with little or even no geospatial experience to be able to go in, select the boundaries for an area they're interested in, the data, the outcome metrics, the other source of geospatial data that they want data on, and get those results in a simple spreadsheet format. And so we took this basic concept and loaded terabytes of spatial data onto our cluster at William & Mary, built out the infrastructure to handle running literally billions of these zonal statistics operations. And then we put together a website that would tap into our cluster and allow anyone to access that data for free without having to do any of the searching, preparing, processing of the data themselves. So since we've launched GeoQuery, the user base has grown. We've made partnerships to tell people about this, reach out to more organizations, and we've ended up with really more users than we ever managed who are benefiting from this and leveraging this for their own work. This has led to new connections, research, opportunities on numerous fronts that are ultimately just driven by the fact that geospatial data has become more accessible. Just putting some numbers to this, over the past 6 years, we've had approaching now 40,000 data requests. It's gone up a bit since I made my notes here. Over 7,000 users across nearly 2,000 organizations. Researchers have been from groups like the World Bank, USAID, local governments, NGOs, and many, many faculty and students across hundreds of universities around the world. And then at AidData, we are still using GeoQuery to provide data for many, if not all, of our geospatial impact evaluations, as well as to distribute now some of our own data on geocoding we do, and to generate training data for machine learning models. So I'll spend the next few minutes just quickly going through actually accessing data from GeoQuery. And if you want to follow along, if you have your laptop, now would be a great time to go to geoquery.org and you can go through this process yourself. I think there's some folks from AidData in the room if anyone's having issues to make sure you get to the right website. So once you're there, the first step is to select a boundary and administrative unit from any of our hundreds of administrative units for every country in the world as your area of interest. So here I've selected Nigeria, and you can select the ADM1 or ADM2 level. And once you've selected your boundary, you can click the Search Datasets link. And what that does is quickly scans our databases and finds all of the different outcome measures and satellite imagery datasets that are relevant to the area you selected. And then once you've done that, on the next page, you see a full list of all our data sets. And here you can scroll through, click on any of these. There should be about 70 or 80 total these days, depending on which country you selected. And there's options ranging from nighttime lights, protected areas, temperature, precipitation, land cover, NDVI. And for each of those, you have the option to select how you want to aggregate that data to your boundary, as well as any temporal information, the years or months that are associated with it. And if you ever want to look at where this data actually came from, those little source I buttons next to the data set will provide a little bit more detail and give you a link to where the data set actually came from. And so once you've clicked add that to your request, you go to your to follow through, you put in your email and everything, you submit it. You don't have to log in, it's completely free again. Anyone can use this. And it processes your request on William & Mary's high performance computing cluster and gives you this permanent page for you to use as a link where your data will always exist. And it'll just give you a recap of your request. And once it's processed, it will tell you it's completed, and you will have a download for the documentation, the tabular results, as well as a zip that includes both the documentation results as well as the actual boundaries and any other data that we can provide that was used to make that request. And so next up, I was just going to give you a few examples of how easy it is and the options for using this data once you've submitted a request from GeoQuery and you have that tabular format. And so here I just loaded that tabular CSV file into Google Sheets. You could do the same stuff in Microsoft Excel or any other spreadsheet software you're familiar with. And you can see here that you have a few columns describing, for each row describing what the administrative unit is. So in this case, I selected data for Ghana on population and nighttime lights. And you can see there's a shape name field describing the region, the ADM1 level, as well as a column for each year of population that I've selected. And in there, in Excel or Sheets, just using some of the built-in tools, you can see it's very easy just with the default chart setups to generate some useful metrics. So we pulled together some plots on population across the regions for each year. And then just to show you some of the other options, styles of charts and what you can look at, here we have nighttime lights across the years for each region, just viewed slightly differently. And then just another option for NDVI. And this is really just using the default suggestions within Google Sheets to make some interesting charts. And the options there are, there's plenty of things you can really play around with and get into the details to get exactly what you need. And if you want to go a little bit further, if you don't want to use just the tabular data, we do provide the actual spatial data file, the GeoJSON, that contains the definitions of the boundaries, which you can load into GIS software and join with the tabular data to do even more detailed spatial analysis. So here I've used QGIS, Quantum GIS, which is a free desktop GIS software that works on all platforms, and there's hundreds, if not thousands, of pages of great documentation and tutorials online for anyone who wants to do anything spatial analysis related. And you can load in the boundary data that I show here, the tabular data, and very easily join those together. So this is just what the boundaries look like once you've actually visualized it. And then you have the tabular data join in, which looks exactly like you have in your Excel sheet when you load it. And from there, there's some pretty simple styling options within QGIS that you can produce really meaningful spatial visualizations. So here we've got an example where I just used one of the years of nighttime lights for the ADM1 level in Ghana to visualize the level of light in each of these regions. So you can see down by Accra on the coast, where it's yellow and brightest, that's where there's the most lights, and that makes sense. It's a major population center. And further in the north, where it's darker blue and there's fewer population centers, fewer cities, it's darker. And you can do the same with all the other data we have. So just corresponding to the visualizations we made in Excel earlier, here we have population. And then we can also look at NDVI. And like I said, with QGIS, the sky is the limit. You can really do everything, and there's tons of great resources. If you're ever in doubt about what you can do or you need to be pointed in the right direction, reach out to me or other colleagues at AidData, and we're happy to share some links with you. And so lastly, I just wanted to show if you want to do your own really custom analysis, if you want to write code to do this, it's very simple to leverage the tabular and spatial data in whatever programming language is familiar to you. So Python is what I tend to use the most. It's a very accessible, common programming language. And I'm just going to run through just a little bit about how little code is actually required to load this up. So with a few core packages for using tabular data, pandas, geospatial data, geopandas, and just visualizations, matplotlib, it's very easy to load in each the tabular data using the read CSV function, and then the boundary data using that geopandas read file. And from there, pandas and geopandas have these built-in functions for the most part to just plot this data. So I just replicated here just a purely tabular data visualization of population at 2 different points in time, 2018 and 2020 for Ghana across the regions. And then just mimicking some of what we did before, it's just to look at the boundaries. You can just call plot on the data frame for the boundaries you loaded, and it'll show you a visualization of that. And finally, if you want to create some of those more stylized maps that show you nighttime lights, similar to what we did in QGIS, it's quite easy to do that too using some of GeoPanda's built-in functionality. And if anyone wants these specific examples, feel free to reach out to me. I'm happy to share those later on. So that's everything. Thank you for joining. Happy to open it up to any questions or discussion that I might have at this time. Thanks.
Thanks, Seth. Is there any questions in the room or online? Go ahead.
Thank you very much, Seth. I think this is very interesting, and I'm sitting down here since I just flew from Ghana. And I was thinking that, how can policymakers and practitioners in Ghana use such data? Because now the buzzword is evidence-informed policy making and action. So if I'm meeting a bunch of, let's say, policymakers in Ghana, and I'm using this one to show them, let's say, nighttime vision, how do I, be able to use different areas that they are interested, to be able to show them what is happening in the country? Is it something that I have to come, or how do I, listen to them and see the areas that they are interested for me to show them, especially Ghana, since they are moving into digitization, because the whole country is now moving everything from payment system to, I'm doing a project on their economy digitization. So policymakers are very much interested, but how do we listen to them and see areas of their need so that we can use such imageries to really let them know what is going on?
Yeah, I think it can vary depending on the application, but I could imagine if they were rolling out digitization initiatives across the country and it was taking place in certain regions, you could pull data on nighttime lights or population for that specific region and visualize the trends there over time. And you can compare that to other regions where maybe those programs aren't being implemented and start to get a broad sense of maybe people are moving to the areas where there's been these improvements. And I think at the core level, even if you had that same data just in a tabular format, that's good, just having the raw metrics there. But being able to visualize that spatially and show that there's these changes being concentrated to certain areas, I think is a really powerful tool. And if your projects, your initiatives, where policymakers are interested in, doesn't align with the data we have in GeoQuery, it is very easy for us to take your own boundaries. If you have health districts or specific subsets of a city where you're implementing programs or you want to understand population trends, we can run extracts of the data we have in GeoQuery for you on demand, custom. It's very easy for us to do that. We simply can't put all the boundaries for every possible combination of units in the world on there. So if users ever reach out to us and say, I'd like data for this specific area that's my unique custom drawn boundary, we're happy to run that and provide you with the exact data you need.
Maybe just a simple question. I noticed when you look at the geographic areas, they're listed as like 1, 2, 3, 4, like different administrative units. Is there somewhere where there's a mapping of those to like normal names, like state, district, or whatever?
That's one of the things we were hoping to include in the future. We've always used just the level because the level is the only thing that is consistent across the world. Some countries, what is a region might be the same as a district in another country. So we're just trying to avoid some of that confusion. When you actually download the data, it does have the name for that particular subset of what it is. But in the future, we're hoping that the source of our boundary data will not standardize that, but we'll include it for each country so we can put it in the description there. The boundary data we actually use for GeoQuery comes from another project at William & Mary called GeoBoundaries. So that's the first continually updated, completely open source collection of administrative boundaries around the world. And that started a few years ago, and they've really been continually ramping up. So I'm only expecting things to improve and get better with GeoBoundaries in the future. And any improvements they make, we'll pull into GeoQuery as well.
Thank you.
Quick question here. Hi, Seth. This is a very great presentation, and I just want to thank you and your team for bringing this all together. I've had a chance to witness how geospatial data has evolved, at least for the past 10, 15 years. And now we're getting to the place where the vision of having data in one place and being able to rapidly work through data sets and start to tinker with different research questions is becoming a reality. So I think one of the major challenges that smallholder farming systems, by the way, my name is Julio Sadopo. I'm from International Institute of Tropical Agriculture. One of the major challenges that we're trying to tackle or address in smallholder farming systems relates to the resilience or the vulnerability to climate change. And I was looking through the data sets, in the GeoQuery catalog. I realized that there isn't any current representation of climate change projections, RCP 6.0, 8.5. And I know those data, of course, are existing in various repositories as it's been, generated by modelers. Question is your team planning to incorporate data set from those sources anytime soon? Can we hope that maybe in the next few months or 1 year we can see that also, being accessible through GeoQuery? Thanks.
Yeah, that's a great point to raise. One of the things we've always considered when we're integrating data into GeoQuery is that it's very sort of best in class. So it's a very curated list. We don't want users to have to wonder about, is this the right quality data? Are there two competing sources? And I think with some of these projections, there's always multiple options depending on the specifics of what you want, especially because they're forward looking. It's not just a historical record from satellite imagery, which is objective. Uh, so it's been a little hard to make that decision about what specific data set we should include. That said, we are always very responsive to what people using GeoQuery need. So if you have a specific data set that you say, I need this for my work, it would make my life better if I had it in GeoQuery, shoot me an email and we will work on getting that in there.
Hi, Seth. This is Tulika again from Mathematica, and I had a similar question actually, and maybe you covered it, and you were beginning to talk about it now. So say a little bit about what's in, like, what are the data sources that you have? What was the basis of, the set that you have included, and the set that's not there, just to get a sense of, what your future plans are of adding the data that might be relevant, or things that you've excluded because of quality concerns or other aspects that you had. So I'd like to hear a bit about that. Thank you.
Yeah, another great question. A lot of the data that we feel most comfortable about including are the most, I'd say, established sort of objective data sets. So something like nighttime light, it is very straightforward. It is a metric of light's intensity around the world, and it's provided by very well-known group, obviously NASA, and it's easy to say that's what goes in there. So other examples are major satellite products. So European Space Agency, NASA, stuff like land cover, temperature, precipitation that we get from those groups. Those are easy ones that we know that is best in class. It is high quality. It's been used in a lot of research. It's going to be supported going forward. So those are our sort of tier one. Then we also include a lot of reputable academic products. So research groups that have taken satellite imagery to produce secondary products. Examples of that are travel time to major cities, or people have used their own approaches to go through satellite imagery or use groundwork to say, where are diamond deposit locations around the world? Or they've used ocean imagery to say, how far is it to the nearest border? The reality is, beyond those, there's no limit to the amount of data and secondary products that are produced. Even within the groups, just if you look at just subgroups of NASA and the products they produce from one satellite, there could be hundreds, if not thousands of these. And we can't include all of them. So we're trying to just anticipate what is most useful for the people using GeoQuery, the kind of data they need, our own internal needs. And like I said before, we're always adding new data. We're trying to be responsive to what's most useful in the development space, to people who are relying on GeoQuery. And if there's other variants of data, or you have questions about what could be potentially added, we're always happy to discuss that.
Sorry, just a clarification, Seth. So these data are largely data that are sort of covering a whole region, but they're not sample-based data, for example, right? That's also another way that you would not include, like, say, living standard measurement survey, of course, solid data, but it's sampled, it's, happening at discrete cross-sectional intervals. So just to sort of clarify what's not in it, that's one category that is not in this group. And
Absolutely. For the most part, this is global satellite-based data that is at a relatively fine resolution. We try to aim to have data that's 5-kilometer resolution or better. We've explored incorporating survey metrics before. It's tricky. Every single question is going to be different from the survey. You have to create a different data set. The coverage is different. So it's a little hard to keep users informed and maintain that curated quality where people don't have to think, is there actually good data for this? And surveys, you have to really think about it a lot. So it's better to leave that to the user in most cases.
I have a question. You've curated a lot of data sets, so I could imagine there'd be an interesting use case where someone who just wanted basically boundaries that are grid cells, maybe down to 5 kilometers. Is that something you would provide, or are there limits in terms of in that regard?
Using very fine grid cells for boundaries is a bit of a computational challenge. We do have some grid cell boundaries in there that align with what was the PRIO grid. That was the Peace Research Institute of Oslo. They had released a static version of conflict-related data similar to GeoQuery's ideals. And that was a half decimal degree, 50-kilometer resolution grid. So we include that in case anyone wanted to use GeoQuery to combine their work. If you wanted data that was at such a fine resolution, at that point, it doesn't always make sense to use the computational spatial operations of zonal statistics. You'd really probably want to work more with the raw imagery. And happy to discuss how that could work for your applications if it's something you want to pursue. And if you have a small area that you wanted fine grid cells for, we could still do that sort of custom extract for you. I see there's one question in the chat about whether the data sets are regularly updated and if it's automated by sources they're connected to. We do try to update these at least once, if not twice a year. Some of them are monthly and updated regularly. Other data sets, the sources just take a bit longer to update them. So some of the ones that are modeled require a bit more time from the data providers to actually produce the next year's data set. So we have, coming to the end of 2023, there's still some of our sources that haven't released their 2022 data yet. We have some pretty robust pipelines in place, but it's not fully automated to sort of trigger from that source and just automatically run. If there's anything that hasn't been updated and you think it may have been released already, you can always ping us and we could run those pipelines a bit sooner if necessary.
Any other questions?
I have a question. So thank you so much for the presentation. You mentioned that you're trying to kind of keep an eye on the priorities and listen to the community in terms of what types of data you're looking at integrating into the system. I'm curious what kind of mechanisms are in place or opportunities are in place to gather that feedback and help you to prioritize which data sets are pursued next?
We've tried a few different approaches over the years, and there's been varying success. Some of it short-lived, some of it sort of ongoing. We've had forums that went out with every request asking users to contribute. We've identified groups or users that were highly active on GeoQuery and reached out directly to them. We've sort of polled our partners that we're regularly working with on projects that might not directly use GeoQuery, but are using geospatial data. And we've discussed doing some broader outreach to just sort of a broad network outreach and say, what kind of geospatial data do you work with? And it's been a little bit tricky. I think some of the more generic options, the surveys, we had like less than 1% response rate of users. So that's an ongoing challenge. A little bit of that is just staying abreast of the literature and looking at research that's coming out of groups and seeing what their uses are. And one of the big things we did when we put together a literature review essentially of what users and what groups have been using GeoQuery over the years. We essentially listed what data did they have in their research from GeoQuery and what were they going to other sources for. And we looked at what can we find in that other sources list that we can add into GeoQuery. And unfortunately, I don't think we're ever going to be able to provide everything that everyone's going to need for their research. It's always going to be a little bit, you have to go find your own survey data somewhere. It's always a bit of a challenge.
I have a question about the spatial aggregation statistics. I noticed for most of the products, it's a minimum, mean, and maximum. I was wondering if you considered any other statistics, like a median or any statistics on spatial variability as well.
Yeah, we have provided median, I think, for 1 or 2 data sets. We could definitely add that for more. Some of the variability and other metrics, more complex metrics, get a little tricky due to some of the technical implementation behind the hood of these methods. Not to get too in the weeds, but essentially to do this, we break boundaries up into very small chunks so that they can run in tiny little operations behind the scenes. So we don't use up all the memory. We could slot these into jobs on the high performance computing cluster. Aggregating those back into one big piece for certain metrics gets very complicated. So something like a sum or a mean is very easy to do. Something like some of the standard deviations get a little bit more complicated. If there's something specific though that you need for your boundaries, we could always run, like I said, custom extracts with that custom metric. We could define a function that does that and run it for you.
Hi, is there a way to use masks, for example? Like if I select a country, I'm not really interested in the entire country, but only interested in rice areas in those countries, for example. Is there a way to use a mask aside from the selection of the boundaries?
Yeah, we've done that with one or two groups before, and essentially the process is taking the broader boundary and then taking a area, defining maybe the rice areas or whatever you're interested in, and building a custom boundary from that we could then use for the extracts. There's not a built-in masking function we have, but we could work with you to define boundaries that cover just the areas you're interested in.
Seth, there's one more question online if you can read it.
Yes. Let's see. I saw you have modus land cover data sets included are derivatives thereof envisioned. For example, increase of land degradation, erosion over time, increase in urbanization, built up areas. Yeah, that's a great point. That sort of speaks to all the different variants and derivations of certain data sets. Modus related is particularly notorious for having so many products that come out of their imagery. We haven't been specifically planning on implementing any of those, but like I said, if you need one specific data set, we're happy to figure out how we could get that included.
Another one online, Seth. Oh, I see it. So for everyone in the room, if you could introduce yourself before asking the question, so those online can understand that, that would be great. Any more questions in the room or online? Oh, there I am on screen. All right, well, thank you, Seth. Thank you, everyone, for asking questions.